It's fine.
All right, I think
And we're
live.
on? All right. Nice. Well, I'll get us kicked off then.
Well, let's see. Make sure we're connected.
One sec, everyone. We're going to do a quick check.
Oh yeah, looks like we're good to go.
Looks like we're good to go. All right. Well, welcome everyone to the February 2021 AWS Meetup presentation. This month we have a pretty exciting presentation here. So we are going to show running Kubernetes Cluster on a Raspberry Pi to kind of continue on with our IoT theme that we've been developing through the end of 2020. And to do that, we're going to show off a sample use case, which will be charting live cryptocurrency data, pricing and trends on Grafana, and that will be backed from a persistence standpoint using AWS Timestream. And I'll get into what those technologies are here in just a sec. And so, quick round of introductions. I've got the AWS Meetup Group founder, Austin Lovelace, with me, and he's going to take over for the second half of this. Full stack DevOps engineer at Stuzo, AWS community hero, and I am Kevin Tin, cloud application architect with Worldwide Technology and an AWS community builder. So let's get going. So firstly, we're pretty excited to announce that we are an official AWS user group. I think we signed up for this, a couple reinvents ago, but we started to incorporate some of the branding, so that's super exciting. And so to get into the actual meat of the presentation, what we'd like to go over today is the client-server solution overview that goes ahead and gets cryptocurrency data and then writes that into AWS Timestream. We'll get into exactly how to configure that writing of data to Timestream. We're going to use it for visualization purposes for this use case. We're going to dive into the visualization element of this, done using Grafana, very popular dashboarding technology. So I'll guide you through those 3 bullets. After that, Austin will get into the setup of the Kubernetes cluster on his Raspberry Pis, as well as the configuration of the kind of bare metal cluster. With AWS and EKS, you have a lot of the kind of complexity of setting up a cluster abstracted away, thank goodness. Very complicated. So Austin's actually going to get into some of the finer points of cluster administration. From there, he'll show how to deploy the cryptocurrency client-server application ecosystem onto the Kubernetes cluster. And he'll also touch on important subjects such as configuration management and secrets management. So here we go. So firstly, and these links are in the chat if you want to kind of follow along and look at the code. We've got a repo out there, the Pi and Kate and Crypto, if you will, repo out there on my user in GitHub. And so in there, to kind of talk about the solutions, we've got a couple applications. One is the Animals app, and that's kind of a simple getting started application. I would recommend deploying that and seeing that work if you're worried about adding in AWS dependencies and kind of overly complicating your first foray into Kubernetes. And then secondly, we have the crypto client server app. And so the server will go ahead and reach out to CoinMarketCap and get data for all of the listed cryptocurrencies. And then it will basically serve that up on an endpoint to go ahead and give me the most recent data about an individual coin itself. And so in this example, I think we're using Bitcoin Cash, Ethereum, which is currently experiencing some pretty nice gains, and also I think Litecoin as well. Is that right?
Yep. Ethereum, yeah. Bitcoin, and Litecoin.
Yeah, I think it's Bitcoin Cash.
Mm-hmm.
Yeah, absolutely. So at that point, once the client app retrieves the data from the server app, it'll go ahead and write out to Timestream. And so to give you a visualization of what that looks like, not within the context of a Kubernetes cluster, but just in general, this is what we're dealing with. So CoinMarketCap has an API that they expose, and if you get an API key, very easy to sign up for. You can go ahead and hit that just using HTTP API calls. So here I've got a Python server app that's going to go ahead and call out to CoinMarketCap, get all of the data for all of the coins, and it's going to cache that and only call the actual CoinMarketCap API every minute. So that way we kind of stay away from some of our API throttling and limitations that they put on the CoinMarketCap API. And so to dive into the client layer of the solution, we've got 3 instances of the same application, just configured differently. One to track Ethereum, one to track Bitcoin Cash, and another to track Litecoin. And so those 3 applications will then go and write into the Timestream database within, and this is kind of the delineation of when AWS comes in. It'll write into Timestream, and then our dashboard, Grafana, will go ahead and pull data from Timestream.
Look at that. You see that? Benji, right? Dogecoin.
Yeah, Benji, I like it. Nice. And so to just go ahead and take a look at the code, let's go ahead and just dive into the actual code base itself. And so here, inside of the repo, in crypto, we've got client and server applications. So let's go ahead and start with just the general makeup of the repo itself and the applications. In here, at the root, we have a Docker file. We'll get into how we're using that here in a bit, but that's used just to containerize the application itself. And then each of the applications have a source directory that have, firstly, the requirements in terms of what you will need from packages in Python land, some settings that we go ahead and get off of the environment. And getting these settings from the environment is very important for configuration management, which Austin will get into later on in the conversation. And then we've got the actual application. And so on the server side, very similar setup. We're using Flask to go ahead and set up the API server that the client is hitting, then the code itself. So from the server side, pretty simple code here. We have a simple cache, and we're going to expose a Flask API. So we go ahead and set that up. We've got a quick health check endpoint just to make sure the app is up and running. And then also we've got the endpoint to go ahead and get current pricing here. So here we'll just say current and then the symbol that you want to use, HTTP GET method. And this will call the get cache prices. And so here, this was pretty cool. This is the first time I've used it. This annotation for the get cached prices, part of the API caching that we have up here, the kind of the library behind the scene keeps the last result and the last timestamp from when this method was called, and then goes ahead and will check and see if has it been more than 60 seconds since the last time this was called. And Stephen, I saw on the chat asking if this is being recorded. This is being recorded. I believe the same URL for the stream will work to access this video later. So thank you for asking. Good question. And so here, in the actual data that we get back, the big JSON object we get back from CoinMarketCap, we'll go ahead and find, based on symbol, the output. And if we can't find any output, and again, this is pretty simple code, just us playing around. It's kind of nerding out on this stuff. We'll go ahead and give you a 404 not found. We don't know what that symbol is. And so likely that means that the symbol does not exist or is not being tracked by CoinMarketCap at least. And then if we do find a match on the symbol, we'll just, since we're returning array here, we'll just go ahead and output the first element that matches that symbol. And then finally, this last piece of code is, when you run the application, we'll spin it up on quadruple zeros and port 8080. And so quick dive into the client application. And this is the Timestream writer. And this is by far the more complicated of the 2 applications. So kind of just going from the top, we create the Timestream, the client that writes to Timestream. And so here, as I mentioned in the settings files, we're pulling stuff off of the environment. In Timestream writer, we use those from the settings file to go ahead and pull things that have been configured on the environment. Quick describe table here. This is part of the Botto3 library to interact with Timestream. And then a get current time, we'll use that when we write into the Timestream database. And so here, a little bit of switching logic. If you want to run the application locally, you can specify your local API host, or if you want to run it within the cluster. We did want to point out, probably could have used one setting here, but we did want to point out that we're pulling service dot namespace here, a dot service cluster local, which is kind of the convention to access inside of Kubernetes.
Yeah, and since you're on this point, just to go a little bit further on this, so inside of Kubernetes, this is like a specific domain that I'll get into further in the talk, but we could have easily just used API localhost and not had any of this logic. The only reason we did this is for demo purposes, to like really explicitly outline exactly what this URL is going to be, and I'll explain why that is later on, but I just want to point that out.
Yeah, good point. And so getting into here, we've got a method to actually write records. I think the thing to really take away here is for each write, we're going to have the time of the data, we're going to have the price, and then the trend. This trend is in the last hour, what's happened percentage-wise with a coin. For example, it could be up 1% in the last hour. It could be down, it could be down 1% in the last hour. So those are the two metrics we're really tracking here. And so this payload here is an array in which we give it the kind of the measure type. The measure, we're going to go ahead and give it the dimension name, which is symbol, and then go ahead and then track the other measure here, which is trend hourly. So what I think really important here to notice is in the dimensions, which basically dimensions, in kind of the data analytics space is, if you think about a fact table and a dimension table, a fact table would be like your metrics, and your dimensions would be how you want to slice your metrics. And so obviously it would be important for us to understand for a given price, what coin is that for, or a given trend, what coin is that for. So that sets this up, and then finally, since we're dealing with time series database, we need to track the time as well. And then that'll go ahead and use that client that we stood up to go ahead and write out to Timestream. And so here within the the main thread, we'll go ahead and create our client. We'll do a quick describe table, quick sanity check to make sure that we are connecting. And then, just kind of a stupid loop here. We'll go ahead and get the quote for, and again, going back into our settings, we have the crypto symbol that we want an instance of this application to track, so BCH for Bitcoin Cash, if I'm not mistaken. And then we'll go ahead and pull back, just parsing through the JSON using a path to the metrics here. We'll go ahead and pull back the price and the hourly trend, and then write that record, and then take a nap for about 30 seconds. It's not a great nap, but we do want to give the server a break. So, that being said, we'll go ahead and get back into the presentation. And so, kind of going through the code, now let's go ahead and take a look at the Docker files and see how we're creating images there. And so we'll just look at one of these. They're pretty similar. And the slide deck that's been published out there, it does have the commands to kind of do this on your own, to where you don't need Kubernetes to run these apps, but we're eventually just going to show them in Kubernetes because that's definitely cooler. So to go ahead and package up, by far the more complicated one is going to be your client Timestream, your Timestream writer app. Here, we go ahead and specify the runtime, a working directory within the container itself. Go ahead and get the requirements.txt file, and if you recall, that is the requirements that we're going to need to install for Python for the application to be able to run. Oh, I'll start there. Back to the good file, and then so on on the startup, we're going to go ahead and run pip install, and this -r allows us to specify a requirements file, and then we'll go ahead and copy our from the source directory here. We'll copy all of our files into our working directory, specify the environment variables. We've definitely obscured some of the secrets here. So if doing this on your own, you will have to come in, modify, and set up your secrets. And then finally, the command upon the container starting up in Docker runtime would be to run Python, and then the argument would be timestreamwriter.py. And so just a quick look, won't go as in depth here. The server is very similar. Noteworthy is it only takes an API key and it exposes a port. So that exposing of a port, if you're going to run this locally, very important. So with that being the case, back into the slide deck, here are some commands if you want to build these out locally and run them. And so here, depending on what directory, crypto-client or crypto-server. And then finally, important to note on the client, we want it to use the host that the container runtime is running on. And so that --network equal host here is critical to get this running on your box.
And that's also in the code base as well, these commands.
Absolutely. So to kind of dive into some of the cool technology that we have used, Timestream, Amazon's definition, fast, scalable, serverless time series database, good for application monitoring, IoT, analyzing a lot of events across time, and it's much easier to do this kind of analysis across time using a time series database, and it turns out it's also much cheaper than trying to do this in RDS, for example. And so to kind of put some definition around a time series database, optimized for dynamic metrics. For example, the price of a crypto coin changes throughout time, so that number is dynamic. That's what the definition means there. And then it can be sliced by static tags. And so as we have the price metric that can be stored for multiple coins across time, the slicing occurs by the actual crypto symbol itself. And so that kind of a high level kind of intro to what is a time series database and what is Timestream itself. Big takeaway from Timestream is it's serverless, it scales, you don't have to set up an EC2 instance. Although that's easy, it's easier not to. And so it gives you the ability to spin up pretty advanced Timestream or time series database without having to understand the underlying infrastructure. And so common examples of time series databases: Druid, InfluxDB, and Prometheus. Very commonly we see Prometheus used to monitor application performance or server performance. And so getting into that point, common use cases for a time series database would be sensor data, application metrics, fluctuating price data, for example, cryptocurrencies. And so with all that being said, let's go ahead and take a look at Timestream in the portal.
Should exit.
Okay, good call.
The problem with working on somebody else's computer.
Absolutely. And so here, coming into the services within the portal itself, find Timestream just by coming up here and typing in Timestream, get into where we are currently. And so let's see, I believe that I have my Timestream database set up in East 1. There we go. And so creating a database is super easy, and the CloudFormation script for this is about as easy. So the standard database, give it a name, take the standard encryption, and some tags and stuff of that nature. So pretty basic here. So stop for a question here. Benji says, is a slice a partition of a coin type, or would it be used to slice time, e.g. prices on Tuesday? Time is a dimension here, so you can slice on time. And I think once we look into Grafana, that ability to slice on time will be very evident. But also the ability to slice is not necessarily a partition of a coin, it's the whole coin itself, if you will. So I want to look at Litecoin, I want to look at Bitcoin Cash, I want to look at Ethereum. So when you apply the two dimensions in terms of slicing and dicing the data, like I want to slice by Bitcoin and I want to slice by Tuesday, that kind of gives you that slice of the partition of a coin that you're going after. So we can kind of jump into that. I think it's a lot easier to visualize that with Grafana and kind of see what that looks like. So good question there, and we'll follow up and kind of cover that in a more concrete way. And so coming out here to my database, just taking a quick look at the tables. I did set up a sample table here, and this is something that AWS has been kind enough to provide that has kind of a mocked out server monitoring use case. And I won't go into that. We have a lot of content, but it's a really cool way to get started. Very easy article to Google and get started with Timestream and also Grafana. And so kind of getting into our database, the crypto database here, crypto data, the table itself. You can get in here, look at monitoring. So we ran the apps pretty recently to get a little bit of data in here so you can see some standard metrics around that. Then get into query editor here, and just to kind of like preview the data within the database. They give you this handy preview data. They also have a schema and measures option here, but this will go ahead and let's see. So this is in the last 15 minutes. I have a feeling we need to expand that. Cool. Yeah, so it's pretty easy to kind of visualize this in a table where we've got a symbol, we've got a measure value, a measure name, and then also a time. And so it's a fairly genericized way of thinking about data, where you have your dimensions here being symbol and time, and then your measures here are measure type, and then also measure name. And so you'll notice price and trend hourly kind of show up right on top of each other in the same columns, which, you know, if you're doing this in a in a relational database, those would probably be two different columns. So it's kind of neat. Think about data just a little bit differently, but it allows you to use data a little bit differently, and it has, serious advantages when you start to think about data points over time. So jumping back into this, I'm not going to go into preview mode because we're about to go and hit up Grafana, but just to kind of level set on Grafana, open source analytics visualization application. It's web technology, very easy to set up. Does charts, graphs, alerts, etc. We're going to cover just kind of the basics of Grafana, and let us know. Definitely would love the feedback to know if I think we were talking about doing like a Prometheus and Grafana deep dive on application monitoring. So if that's something that you all would like to see, with Kubernetes, of course. Cube everything, said Austin recently. Cube all the things. Then we would love to create that. We just want to make sure it's something that the meetup group would like to see. But anywho, just a quick overview of how to create a Grafana instance. This is how I did it. There's a few different ways. There's a container. We just kind of went the EC2 instance though. So create EC2 instance, SSH into the instance, so you'll have to set up your security groups and your ports. Don't make your public IP open to all IPs, just a quick suggestion there. So pretty easy instructions. All of this stuff can be done at the command line. I've used the OSS release, the open source software release. There is an enterprise version of it. Would recommend if you're talking to your clients or your company and you want to get into something that's managed and secure and has kind of some governance around it. I won't go too far into that, but I think for a production use case, you definitely would want to take a look at the enterprise version. And I saw the comment, Steven. So yeah, I think we should probably go ahead and put the Prometheus and Grafana content together. So thank you for the feedback there. I always love to hear from the meetup. And so diving back into here, there is a Timestream connector that has been created between a partnership between AWS and Grafana, and so it's just a simple command line installation, restart the service, good to go. So very easy. Could easily script all of this within a Docker container and run it in Kubernetes.
Yep. Unless you're on a Raspberry Pi, then with the operating system we use, I tried to do this, and I would have to basically re-architect the Docker image because it didn't have the right compatible runtime for it, or right processor for it. So
turns out tiny computers
are difficult.
Yeah. Well said. So then once you get into Grafana and it having the Timestream connector, last piece of this is to create the data source and create the panels. And so to jump into that, went ahead and let's see. All the data. I've already set all this up, but just to kind of give you a recap of how this is done, in your data sources, add data source, Timestream. So pretty easy point and click stuff there. I'm almost positive you can script this as well. Then, it's just basics here. One thing I did notice, I was going to deploy into West 2, but I noticed in the drop down here that it's EU West 2. I don't know if that's a typo or they intentionally just only included West 1 and then wanted Europe's West 2. So I ended up putting my Timestream database in US East 1 just to avoid any kind of weird behavior, inability to find the database. Went ahead and gave the kind of the default database crypto, the table, and also the default measure. So pretty good stuff there. Then it gets into creating your dashboard. So to create a dashboard, pretty easy. You get in here, and then there's the concept of panels. And so to create a new panel, you end up basically specifying where you want data to come from, and for example, what measure you might want. And so that being the case, you can kind of point and click your way through this stuff, but I think it's cooler to look at the actual queries themselves. And so in each panel, I've got this out here for you all to grab if you want to replicate this on your own. Let's just go ahead and go through. I think it's probably more interesting to take a quick look at the historical graph of either of the metrics. The gauges are cool. A historical graph, I think, gives you more of a sense of what this create Timestream function does. So jumping into here, go ahead and take a look at the editor. And so here, we're going to go ahead and get symbol out of the database, as that's our metric. We're going to create a time series across the dimension time, as well as the measure value double. And if you remember from the table, measure value double is the column name. And then you can also filter on the measure name, and here we're going to use price. Have to group by symbol, as this could be, in this case, 3 different symbols at the same time, potentially. And then also here, I've got some kind of nuance from Grafana itself. You want to go ahead and say from the kind of these keywords here, database table, and then also time filter here, because this allows us, when you start to apply this, allows you to change tables, for example, and you can do that through selections in the UI without having to actually modify the query, as well as the time filter itself, which you'll see up here. We've got, this is pretty sweet on Grafana. You've got kind of these built-in time ranges. You've also got the ability to use kind of this domain-specific language to specify your own custom time range. So getting into, say, like the last hour, last time we ran the apps was, pretty close to an hour ago. And we've also got the this refresh interval here. So if we were getting new data at this point, we will later in the meetup, then this would refresh the UI every like 5 seconds. You can also do that manually if you want to turn off the data and just hit the button. Pretty cool aspect of Grafana is you can drag and select an individual time frame, and then it'll go ahead and slice the data based on what you selected in your drag and drop time selection. And if you didn't have the where time filter applied there, that would not work. So important to include this where time filter when you get into these panels and defining the queries that are going to provide the data that drive the panels. So I'm not going to get into all 4 of the panels and their queries, but I am going to go ahead and get into the dashboard itself. So by default, we're looking at the last 30 minutes. Our data is a little older than that, and we'll generate some new data before the end of this. Get in here, and you actually start to see with the different panels kind of the goodness here. And so to kind of key in on where we've got data, again, that drag and drop goodness that Grafana gives you. These gauges up here will give you the last value within that window. And so here, You can go into your panel, select different visualizations. For this example, I've got graphs and gauges. And then last not null is so you have some options you could do first, you could do min max, you can do mean, all sorts of stuff. So I'm just pulling the last. So this would represent, for the data that we have, the last price that they have. So good news for the crypto coin owners. Looks like prices are up today. Ethereum looks like it's really popping, so that's pretty cool. So here, honestly, the gauge visualization uses roughly the same query that we use for the historical charting, and it's just a different kind of visualization. So with all that being said, here you can see as you start to hover over the historical graph itself, you can see the individual prices, and they have them color coded, pretty nice with a legend down in the bottom left. Similar thing here with the trend. So what we're seeing, here at the trend, about an hour ago, within the last hour, Ethereum had jumped almost 2% hour over hour. Pretty serious gains. So, if you were to come up with a use case as a trader of crypto coins, you could pay attention to these gauges, and when you start to see maybe, something, trend up in terms of the trend line over the last hour, maybe it's time to make an investment. Certainly not an investment professional. Do not take advice from me on that front. You will lose your money. But, you can kind of start to think of use cases just, thinking about the data. And, this visualization gives you a really nice way to surface it all in one place, multiple forms of looking at the same data and putting, multiple measures beside each other to see like what kind of correlations, you could maybe derive. And so with all that being said, get back into the presentation itself. And, to kind of round it out here, I've got a screenshot of, what it looks like. So you can see definitely that the price of Ethereum's up, almost 300 since I made the slide deck a couple days ago. So pretty good stuff there. And so with all that being said, the really fun part is how do we put this client server application ecosystem on a Raspberry Pi? That's right, Benji, this is not financial advice, and I am not a lawyer either. So with that being said, I'm going to turn it over to Austin to dive into how we went ahead and put this into a Kubernetes cluster, and more impressively, a Kubernetes cluster on a Raspberry Pi. So with all that being said, I'll go ahead and turn it over, and here we go.
Sweet. Round of applause, Kevin.
Thank you.
The apartment. All right.
The sound of one hand clapping.
Let's see. Okay. Rearrange all the furniture now. Okay. Yeah, thanks for that, Kevin. That was really good.
Thank you.
Okay, let's see where we're at. Our first collaborative meetup together. This has been an experience. Okay, so like Kevin already mentioned before, basically we have a couple of Raspberry Pis inside my apartment that are running a cryptocurrency application, sending data to Timestream and AWS, and then we're visualizing all that with the front end with Grafana. So really interesting use case there, but I'll go into like how I set that up with Raspberry Pis and why, and I'm gonna get into like some of the specifics around Kubernetes as a whole of like different API types and why we used what we used and what we did use. And then I have an architectural diagram at the end to encompass everything that we already have from the application itself to Kubernetes and the whole bunch. So, all right, let's see. Gotta remember what my slides say. All right, so solution overview, pretty much that's what I just covered. So Raspberry Pis and why. So the long story of it is I just started a new job at a new company a couple months ago, and their architecture is all on Kubernetes. They recently just switched. And so I wanted to ramp up to where they were at, understand how I could be like a bigger asset for the company and help out as much as I could. And so I wanted to start learning Kubernetes. So I started picking up like a Cloud Guru course and everything like that. And I picked up a book, an O'Reilly book called Kubernetes Up and Running, which show you guys. It's a little bit outdated, but the overall concepts are the same. And in the back of the book, they have a chapter where it shows you how to set up a Raspberry Pi Kubernetes cluster, and it's outdated and it didn't work very well. But that's where the inspiration came from. That and the idea of like, okay, so if I'm running everything on EKS or AKS for Azure, whatever it may be in a cloud provider, a lot of the heavy lifting of setting up your actual Kubernetes cluster and everything behind that is handled for you. And so I wanted to remove some of that and really understand what exactly was going on behind the scenes. And so my way of going about that was to use bare metal. And this kind of goes into talking about that, about how Kubernetes is a difficult concept and the cloud providers kind of hold your hand a little bit. And so this is a way to really get a little bit more in the nitty gritty. Of course, there's third-party tools to help you out as well. So for basic hardware component of the Kubernetes cluster, we have 3 Raspberry Pis. One of them is a Raspberry Pi 4, 2 of them are Raspberry Pi 3s. The Pi 4 uses my master node, and I'll go into a little bit more detail on that. But we use the master node as the Pi 4 because it's where all of like the most important data of my Raspberry Pi is going to be at, or of my Kubernetes cluster is going to be at. And then we used a 5-port gigabit desktop switch, which is that really cheap TP-Link. I'm sure there's better options out there, and probably not using the best thing. But I picked that up recently just to get something cheap up and running. Have everything connected with that. And we have a few SD cards. I think they're about 16 or 32 gigabyte. And so all of that is inside of the Pis as well. One weird thing, I probably did something wrong, is with my Pi 4, I did some traveling recently, and every time I would unplug it from the power and everything, it would just like corrupt and crash my SD card, and I would have to basically reinstall the OS on top of it. And it was a nightmare. The reason we had to push it back a week is because installing all this was a nightmare, but it was a fun learning experience. So talk about installing everything. We used an operating system called Hypriot, which I learned from the book, which, like I said, is a little bit outdated. But Hypriot is a Raspberry Pi optimized operating system for Docker. And so it already comes with Docker pre-installed, which the new Raspbian OS does already now, so there's really no point in using this. So I don't really have instructions for how to set that up, because you could just use Raspbian and save yourself some time. But Flask is this brew utility that was able to basically put that operating system onto my Pi and put that onto the SD card, which I think I actually forgot to put in here. Oh yeah, I actually had an SD card reader as well, and I didn't have a link for that, but that's how we were able to flash that Hypriot OS onto the Raspberry Pis. So then with setting up Kubernetes itself, and I'm going to add all these documents into the README. I ran out of time, and so it's not there yet, but expect like a full comprehensive tutorial on how I set up everything from start to finish inside of the README. But so what we use is this tool called kubeadmin, and this is how you're installing Kubernetes onto your actual Pi and setting up your master node and everything like that. And so this kubeadmin will generate a token, and then that token we can use and add worker nodes to it, which is the 4th step of this. Before that, you want to initialize your master node with kubeadm init, and then you want to install Flannel, which is similar to like a CNI, which is like basically a way of adding a virtual network inside of our Kubernetes cluster so that we can communicate with everything. And without setting that up, then you have a little bit deeper detail of Kubernetes, but a bunch of things break more or less with the actual master node configuration within your kube proxy and core DNS and everything like that that's going on to manage all the networking. So we installed Flannel as the open source one for this. AWS allow crypto mining. I'm not sure. I wish I knew how to mine crypto, but I have no idea. We just used a open source API to do that, Daniel. Daniel's question is AWS allowing crypto mining. Not to my knowledge. I'm sure they would shut that down really quick, but yeah, we have like this open source API that we're calling every few minutes. All right, so then yeah, we can add the nodes to our cluster because it's going to give us a token, and then that's the way that we connect our 3 Raspberry Pis together within the nodes themselves. Yep. So you guys got it figured out. Max has the solution to this. You can do whatever you want, but it's probably not a good idea. So anyway, yeah, I guess you could do it anywhere else. It's not gonna be expensive though. Exactly. There's no way you're gonna make money out of that. Yeah, that's true. Okay, so then gotchas with bare metal. So a couple of the problems that we faced with setting this up was if you are using a service, and I'll explain what that is in just a minute, but it says can't host Parler on EC2 instance. Okay, you guys are distracting me. All right, so
Got 'em.
so gotchas with bare metal. So we were trying to set this up to where I could have public internet access come through my router and then hit the Raspberry Pi, and initially I was going to have Grafana inside of the Pi, and it just became like a little bit beyond the scope of what we wanted to do. We could have set it up, it would have been a little bit more of a challenge. And this is also kind of what my second bullet on this is talking about. But with using a load balancer, whenever you set that up with like a cloud provider, it automatically deploys like an elastic load balancer for you if you're using AWS. But whenever you're on bare metal, you don't have any of that support with you. So I used an open source load balancer called Metal LB, which basically sets up a network load balancer for you, and then provides external IPs for your pods, which is only external within your own local network, not external to the world. To do that would go to point 2, which is resource right here, would show you how to do that. If you guys are in the slides, you could go and check this out if you wanted to try this on your own. But basically this is a way where you could break through or open up your router's firewall and allow internet access into your home network so that people can interact with your Raspberry Pis, but we didn't set that up for this. So with deploying the actual application, and I'm going to get into a little bit of the specifics of Kubernetes itself and what we used each of these called like API primitives inside of Kubernetes. So I'm going to define them and I'm going to explain why we use them and what we use them for. But if you wanted to go see the Docker images, or if you wanted to pull them down, like you could just either go to the repo and look at the images we use, or build your own image. But it's all under my username, Austin Lovelace. But for the deployment itself, so like Kevin said, we have, and this is mostly me talking about the crypto application, but we do have another application with called it like the Animal app. It's a pretty basic application, just kind of like get your foot wet with Kubernetes to learn some of the basics. But the rest of this we'll talk about the crypto app. I'll show the Animal app further down the line, but for now I'm going to explain the specs behind the resources of Kubernetes and why we use them. So pods is probably one of the easiest places to start, because I'm sure you've heard about pods. So where they got this name from is Docker's like mascot, or whatever you want to call it, as a whale. So a pod is a group of whales, and that's where that name comes from. So a pod is the smallest deployable unit of computing that you can manage within Kubernetes, which all that means is that's the lowest level of an actual like compute instance you can have. Which, if you wanted to picture this as like a hierarchy or like a diagram, you could picture a node at the top level, which is your virtual or physical device that is hosting your pods, and then a pod can manage multiple containers at a time. So you could say like you have a node with like, I don't know, 2 pods, and each pod has like 2 containers, and then it's like one inside of the other. And that's like one way that you could visualize this if you're more of a visual person. And then like I said, with the node, it's a virtual or physical machine. So for my instance, it would be the Raspberry Pis, or if you're in AWS, it would be like an EC2 instance, or if you're using Fargate, it's still EC2, but they're managing all of that for you. So moving on to our deployment spec for a replica set and a job, and why we use these. So a replica set is just a set of pods replicated X number of times. And so inside of the application, I specified that we wanted to have 3 replicas of our server, and I'll show all of this whenever we get into the actual code base. So we have 3 replicas of the server, and maybe a reason you want to do this is to add redundancy through for your application, because it could spread each replica on separate nodes. So let's say like one of my nodes went down, one of my Raspberry Pis went down, and it had 2 of my servers, but the other one was on a different node. Then my whole application's not going to completely crash unless it just gets overwhelmed with traffic after that. But ideally, this adds a little bit of redundancy, and so that's why we wanted to add this, to show like a little bit of best practices inside of Kubernetes. And so that's where the server lives for sending data up to the Timestream database. And what we used to call the cryptocurrency API and send that data into the server, which then sent it to Timestream, we used a job for that. And this job, how we have it set up, since we have 3 different configurations as far as we were using Bitcoin Cash, Ethereum, and Litecoin. The Bitcoin, all 3 of these are separate containers. It's the same application code for each container, but with different environment variables for each one, which is defined within my job spec, which I'll show you, and we'll get into the code, and I'll recap this again if it doesn't make sense right now, and we can actually visualize it. But that's basically what this does, is it calls it every 30 seconds, right, Kevin?
Yeah.
So every 30 seconds it's going to call whichever one for each container, and then it's going to send all of that to one of my replica set servers, and that server is then going to take that data and send it up into Timestream. Actually, I think that's not exactly correct, but that's the idea. So then moving forward, we have namespaces, config maps, and secrets. So a namespace should have been maybe on the beginning slide, but a namespace is the overall like virtual cluster, you could call it, that encompasses all of your applications within like a specific, like, I don't know, a good way to reference it. Let's say like for my application, I have the replica set, I have the jobs, I've got config maps and secrets, which I'll get into what those are in just a moment. All of that lives inside of a namespace. So then that namespace is separated from another namespace. So I'll show you whenever we get into the command line. I have one namespace that's called app, which is my animal application, and one namespace that's called crypto, which is my crypto application. Those 2 don't communicate or like connect with each other at all. They're completely separate from one another, almost as if they're in completely separate regions of the world, you could say. Like, obviously that's not the case, but the point is they don't talk to each other at all. It's all separated within the Kubernetes architecture. So this is the way you can separate your applications. So moving forward, we have a config map and secrets, and the config map is where we store a lot of information, like the name of our Timestream DB, just environment variables in general, and a key value pair. So the definition from Kubernetes is a volume used to store non-confidential data in a key value pair. So that's more or less what we're using that for, is like what region are we using, what's the name of our Timestream DB. I think there's another one, I can't remember exactly what it is right now, but we'll get into exactly what those are in a moment. That's kind of at a high level what a config map is. And then at a secret, think of it as very similar thing. You can add more than just key value pairs, but for our use case, so it's just key value pairs. This is where we stored our AWS access keys and our API key for connecting to AWS and connecting to the cryptocurrency API. And so this is just where you'd want to store like more sensitive information. So config map is like non-confidential information, key value pairs, just environment variables. Secrets are like sensitive information. You can store whole files in those. Like if you add a PEM file that for whatever reason would connect SSH into an EC2 instance, I don't know why, but let's say that you had that, you could store them into a secret. And a namespace isolates all of our resources from one another. We can have multiple applications inside a Kubernetes cluster that are completely separated from each other through a namespace. So then the last API type that we used in Kubernetes was a service, which everything that we've talked about so far isn't like super conceptually complicated. Like replica sets, group of pods, pod, group of containers, a node, group of pods, namespace, isolate your resources, config map, environment variables, secrets, confidential information. A service is a little bit more complicated, quite a bit more complicated in my opinion. Possibly the most complicated part of Kubernetes, because that's whenever you're getting to the actual the networking of Kubernetes, and this is what I think really makes Kubernetes Kubernetes. Basically, services are a way that we're going to expose our applications to one another, and to say like, give it a domain name or an IP address, and the service will automatically allocate that. And these are all internal to the actual container itself, or to the cluster itself. And so, for example, at the bottom here, the service would give my pod an IP address or a domain name. And if you want to reference back, I'll go ahead and show you after we look at this. Previously, we spoke about the API URL that was being used to call our server from the crypto client application, the one that's pulling data down from the crypto application and sending it to the server. It's happening through this URL, which is the service name, which will define. So for this application, we have like a crypto server and a crypto client. And so for the crypto server, it's called crypto server-service. So it would be HTTPS crypto-server-service. The namespace, like I said before, is crypto, and then .svc.cluster.local. This is the default domain name that Kubernetes provides per pod. This is editable, but we just left it as the default. I imagine, I'm not 100% sure, but I imagine most people probably leave it as the default unless there's any particular use case to change that. Or you could go by IP address, but this is going to be constantly changing, and so you would need to, I'm not sure how you would want to make it so that can be static. There's possibly a way. But going into the actual code, if you wanted to see what I'm talking about here, this is the URL that's being called. And so what this would look like would be http settings.svc. Crypto. Okay, so this is what the domain name ends up resolving to whenever this is all filled in. So this is more or less what we're going to be hitting from the client application to hit the server rep. This is what the server rep will be listening for, or what the server will be, living on inside of Kubernetes. And how all this connects inside of the code, like Kevin talked about before. For our instance, we have the settings pi, but what this is doing, it's just a way of separating and making it a little more modular with our code. But it's just getting environment variables from the OS, and so we define all of these inside of Kubernetes. And with our config map, which we spoke about here, this has a volume, just like a data storage that would live onto our pod, and then the pod or the container has access to that volume and is able to pull out all of the environment variables. And so now right here with this OS getty SVC, which is service, then that would be filled out to say crypto-server-service. I just want to like really touch on that point hard, because this is, like I said, the most complicated part of Kubernetes. And so going into it a bit more, I pretty much just touched on this, how we're using crypto-server as the name for our replica set and for our service. And so we're opening that up on the crypto-server-service. And like I just typed out, this is the URL that is going to be generated from Kubernetes so that we can call that from within our application within the same namespace. So to look at a definition of a service right now in a replica set, So right here, this is this is a really simplified version of it, but this is the replica set. And so I'm calling this, we have like some metadata about the replica set itself, which like I said before is a replicated set of pods, which pod is just a group of containers. And so we're calling this the crypto server replica set, and in the namespace crypto. And you can see this is also a namespace crypto for this service. We're giving it 3 replicas, and we've got a container defined, which is our crypto server replica. Right here, I wish this thing would go away. Let's see. I don't know how to get that to stop popping up. Well, I'll just talk about it instead of being on the point. So you see where it has the image, it's pulling from my Docker Hub and grabbing what the image name is, and since I don't have a tag defined, it's pulling latest. Then we have this env from, which is where the environment variables are going to come from. For the server app specifically, we had nothing that we needed to store in a config map. We only had one secret, and that secret was a API key. And so there's multiple ways that you could define how you pull secrets. This was the way that I used, and this just references the secret volume. And so the secret itself, which isn't shown in this slide, but we'll see it in the code base, is called server secrets, which is pretty terrible naming, but that's what it is. And so we're just referencing that secret, and then whatever secrets are inside of that our application can use. So then one other thing to touch on with this, so you can see within that container block, we have a ports block and then that container port. That container port, if you remember in our Docker file, expose 8080, and then we see our server code, and it's listening on port 8080. This is where this gets connected. So we have the container port 8080, so that means that inside of that service we have, or inside of this replica set, we have 3 containers running, all the same, all running on port 8080. We have internal load balancing from Kubernetes, which handles which server to hit. So the question is now, going on to the service, how does the application know to hit container port 8080 whenever we don't have any kind of ports defined? If you look at the Timestream writer, and you look at this is the URL. There's no ports defined anywhere. The default HTTP port is 80 though, so keep that in mind. There's no ports defined anywhere for this application. So how that gets connected, is through the service. And so the service has a couple of objects that it defines with ports, and like all this other stuff is just metadata, but port 80 is the internal port that the service is listening on, which then you would call that service domain name through whatever port we have, which is 80, which seems to make the most sense. We don't have to define a port. And then it will then direct traffic to that target port 8080, which is the container port. So then it all resolves back to that container just through a couple of layers. The node port is a port that is open for the actual node itself. So if you had the IP address and this was public facing, we could go to whatever the node port is, or to the node IP address, and then type in that port 32001, and it would give us this service. So that's what that does, and I'll show you this in the command line. So then deploying pods with different configs really quickly. This is a snippet from the jobs. This isn't the whole thing because it's quite long, but this way we have containers. We have 3 separate ones. This is all YAML syntax. If you don't know, this is basically just an array of, this right now is 2 items in an array. And so how this is defined is we have this env block, and right here we have our env from, which is a secret ref and a config map ref. Same idea as what I said earlier with the secret ref. Same thing with the config map. It's referencing the config map volume. But then we can also define explicit environment variables, and I did this just for demo purposes. Otherwise, this all could have been in the config map. But right here, I defined this crypto symbol, which we're using in the Timestream map, and we're giving the value of BCH, and right here we're giving this the value of ETH. This is for Bitcoin Cash, and this is for Ethereum. So then this job is one defined job, but has 3 containers inside of it, and these 3 containers have separate environments for the crypto symbol, so that they call different APIs. That's the point of that. So then lastly, this is the overall architecture of the application. So touching on from like the highest level and getting into more nitty gritty. So we have this crypto namespace and the app namespace. The crypto namespace is where most of what we've talked about today is at, and this is a little bit more of a simpler app. And so within this we have this whole node that this is living on. And then we have our crypto secrets and our config map and our client secrets. So this is the server secrets and client secrets. And then we have our crypto server service, and so then our job and our replica set. So replica set has 3 pods, these are all replicas, and our client job has 3 containers, each defined with either Ethereum, Bitcoin Cash, or Litecoin. And then this way we can make a request through the /current/symbol with the domain name of the service to the crypto service, and then this is how our application is connected. And our crypto client reaches out to the Bitcoin Cash or the cryptocurrency API, and our replica set sends that all to Amazon Timestream, or I think actually that happens in the client, but and then over here we have a little bit more of a basic application, which is just replica sets and services. And one, I'll show you how this works. We're just adding animals to an array, and so I just hit an endpoint called get add animal, and then whatever the animal name would be, and then that sends a post request through Axios through my actual service of and hits the service 2, which stores in state an array of animals. It's a pretty basic application. So before we go any further, any questions on anything about that? That's a lot of Kubernetes stuff. This is like, if you needed to know anything about Kubernetes in particular, definitely know services, but overall I think that this is a really good point of getting started with Kubernetes, to where you could go and be somewhat of a useful hand in any kind of already established Kubernetes application, with at least understanding how these basic concepts work and how a service can connect to another service, because that is like the core of all of Kubernetes, is their internal networking. So if you guys have any questions, let me know. Close some of these out. All right. Okay, so just want to show a little bit of the code. We're going to wrap it up here pretty soon. Let's start off with this app. So right now, if I use kubectl, which is the command line tool for Kubernetes, I can do git nodes -o wide, which would show all the IP addresses and everything that they're running on. So then this shows my different nodes, and I defined these host names for my nodes themselves whenever I flash the Hypriot OS onto them. And I can also SSH into these nodes with that host name. And also the command line is set up here as well. So we could do git pods or git po -a, which is all namespaces. Alright, and then we can see it inside of this, but let's go back. So first, I just wanted to show you what we're going to start doing. We're going to get into the kubectl command line, and we're going to do that as we talk through this a little bit. So really quickly, we have this namespace, which you could see from kubectl get namespace, and we have app defined right here, and it's defined right there. And so how we can use this file is with kubectl apply -f app, and since I'm in this directory, it'll apply all of these resources inside of here. We're going to do that with the crypto app in just a moment. I already have the animal app already running. And so I defined this service, and I have this as type node port. I'm not going to get into the specifics of what that is, because it's going to be a little bit of an overload, but So we defined a service, we defined a replica set for that service that has our app1 with the latest tag. We have another service for our app2, have its port defined, and our replica set for that. And these ports could be 80 as well. This could be 80. I explicitly didn't make it that so that you could see why or how this works and how this connects. If you didn't define this, it would default to 80. But we have it defined because this is the port that our container is running on. So if you wanted to see this application run, like I said, we don't have internet access out, so there's not going to be any endpoints for you to be able to go to. But there's a command line tool you could download if you have a MacBook with Brew called port forward. And so with this, it'll port forward all the services. Let me show you those really quick, actually. So SVC is just short for service. -A means all namespaces. If I didn't specify that, it would give me the default, or I could say -n and say app, and it would give me the ones in that. I usually just do -A just because I'm used to doing that. So right now we have app as our namespace, and we have app1 and app2. These are both node ports, and we have this internal cluster IP. So how we can make this publicly accessible for at least my machine right now is I could port forward all these services so that I could see them in the browser. So now we'll show port forward. Alright, so then it's going to port forward these, and it's going to give me the domain name right here, appservice2, running on port 80, which is the same port we saw right here. And it's running like these separate pods, and you can see the port that the target port that the pod is running on. So we can say HTTP port 80, and I have a couple routes here. We're going to see this list animals route. So I have a couple of things already in here, and all this app does, like I said, is add new animals from one service to another service. So how we can do that is I'm going to go to service number 1, and I'm going to go to /add animals, and let's say bear. So then it just has access request sent. Since I have 3 replicas, I'm going to hit it a couple of times so that we can make sure that we see some data in here. So then if I hit this, I see bear, bear, bear. So what happened here seems really, really basic, and it seems like, why are you showing me this? This is like the stupidest app I've ever seen. There's actually a lot going on here with the internal networking, which I'm gonna hit on it one more time, and I'll shut up. It's like the hardest part to understand whenever you go build this. At least it was for me. I don't come from a networking background, so maybe disadvantage, but if you look at that application code itself, and you see right here, we are making this URL with our service, our namespace, and this .svc cluster local /animals/new animal. This is my GET request, which is sending a post request to this endpoint, to this URL. So how that's happening is right here. All it's doing is pushing data into this array. So this is running on port 3001, this is running on port 3002. So it's not like you have a domain name that you can really provide. You have to use the domain name that Kubernetes gives you, which is this. Getting this domain name right makes all your problems better. That's why it was difficult for me, because I didn't get the domain name right the first time. So then now with this service open on port 80, and this service open on port 80, and then in the same namespace, they can easily communicate, and it's like no problem, piece of cake, really easy. And we define our target port, which means that it'll hit 80, resolve to port 3001, which is the port that container is listening on, and so on. And so you could define multiples of these if you had multiple apps that needed to listen on here inside of the service, and we can make it more complex that way. That's how services work. So if you wanted to learn services and the basics of Kubernetes, I would look at animals. To get into a little bit more complex stuff, let's look at the crypto YAML. Let's go ahead and deploy that. So like I said earlier, we can deploy everything with kubectl apply-f for the file and this crypto YAML. I'm in the resources directory inside of my AWS meetup group, Kate's resources. So I'm going to apply that. So this will go ahead and start creating all of the services that we have. So we have quite a few. We've got the namespace it's going to create first. We've got the secrets, which we've got 2 batches of that. And we've got 1 config map, a job, and replica set. So how this works right now is this is base64 encoded for the secrets, which if it's not, it will not work. It'll throw you an error. So you need to make sure you base64 encode this, and also make sure that you remove any new lines. I think you do it with like a -n flag. I'm not going to show you my command because it has the actual secrets inside of that. But for demo purposes, like this is how it's set up, base64 encoded for both of these. Then we have a config map, which like I said before is key value pair. So this is the database name, table name, region, and all of this is just the values like plain text. And then inside of my server or my settings, oops, wrong application. You can see we have like table name, database name, all these different variables that are defined here. And like I said, it's just a volume that sits next to your pod, and your container has access to that to pull those values out. So this is where you'd store credentials like that. Or you put in a secret, whatever you feel comfortable with. So then to show the job, like I said, we define the job client, crypto client job, all in the crypto namespace, crypto namespace, crypto namespace. Here's the namespace definition. We have our container spec, so you can see I commented which ones are which. So this is the Bitcoin Cash. So this is one container, the exact same container definition for each one, so the exact same code. The only difference is I'm giving it a different crypto symbol. So Litecoin, or I feel like I just blanked on what that's called. And Bitcoin Cash, what's it called?
Ethereum.
Ethereum, there you go. All right. We've touched on this quite a bit. So here's my replica set, my service, container port, target port, node port. This really doesn't matter. I just put it there so you can see it. And then the last thing is my other service, API key, which we add this to the container like this. env from secret, name of the secret. It's called server secret, Same thing you can see up here. Client secrets, added here, all the same. So now that we have all those created, we could do git po-a, and we can see the namespace for these apps. So since we have 3 pods because we have replica set for each of these defined as 3 replicas. And then we have a replica set here for the servers defined as 3. And you won't see 3 pods for the job because we didn't define 3 pods. We defined 3 containers. So how we could see that, or at least how I could get it to prompt. I'm not sure exactly how we could see it from here, but if I wanted to see the logs of this, I would say kubectl logs, whatever the pod is, the namespace, crypto, and then it says choose one of these, and then it gives me the name of each one of these: crypto client, BCH, Ethereum, and Litecoin, which is defined here. There and there. So then if I wanted to see the logs, which I don't think there will be any because it should have been all successful, I can do -c for container, crypto, client, BCH, -n, crypto. No logs, but we will see logs here. So for our server, we log every time we get a API request to send that data to Timestream. And since we only have 1 container running, I'm not going to specify the container. But here I can see get current Ethereum, Litecoin, and this is being sent from the client application. So this is how we know it's working. I'm not going to go in great detail about what this is or what this is. The metal LB, I would research on your own. It's a whole different can of worms to talk about this, but this is the third-party load balancer. And why this is here and why we even added this and left it, it really does nothing other than if I show you all of my services, since we just defined a couple more services, or the whole crypto application, we now have this crypto service in the crypto namespace with the load balancer type. The load balancer type is given an external IP, which I defined what that IP address or what that CIDR address range is, and that is I think it was like 10.244. .o.o 0 might have been what it is. Yeah. And so that assigned an external IP to my load balancer service, which, since we don't have any external stuff, it really doesn't help us. But this would be a stepping stone to get you towards that part inside of a bare metal cluster. It's using some like metal LB and then some router manipulation. And then with my ports here, with this is the port internal to my cluster, port 80 for my service. You can see that here. And then I just wanted to touch really quickly why we even defined the node port. These are all ephemeral ports, but if you define them, then they're going to be static, which could be good for your application if you wanted to like specify this and always know what it is. So that's why that's specified. Otherwise, we can run the app. Sudo kube forward crypto. This is going to port forward that service. So now I have that one service. And we can see it returns some of this data for Bitcoin Cash or Ethereum or Litecoin are the three we have. And then we can go back to Grafana, and Kevin might have to show me how to use this better, but we should start seeing more data start coming in through Grafana. The last 5 minutes. Sweet. So this is like the most up-to-date data that we have, with Ethereum still kicking ass.
Well, I think if you look at the trends on the right, it looks like there's a little peak earlier that we found, and now it's starting to trend back down. Very interesting.
Oh, yeah.
It's a super powerful way to look at information. Like Grafana's visualizations really are, I think they're pretty enlightening. You know, for something as simple as 2 metrics, you can tell that, you know, over the course of the last hour, it went through a bit of a peak and then now it's starting to simmer down a bit.
Yeah. Yeah, no, this is great. Need to use this in real life.
I think we should go back to Benji's comment on the chat. I am not a financial advisor.
There you go. Kevin doesn't know what he's talking about.
I don't know. That's one way to paraphrase it.
Okay. All right. So to recap, this is pretty much what we built on some Raspberry Pis. We have a basic application where we're just adding animals to an array and local state, and a Node.js application that uses replica sets and services. Really basic, get your feet wet into Kubernetes, try to replicate this in Minikube, or if you want, go forward and put it into EKS. All you need to do is set up your kube CLI, kubectl CLI with your kube config, which I'm not going to go into in this talk. Maybe for the next talk we can talk about the nitty-gritty of like every single aspect of building a cluster from scratch, possibly, if that's something you guys would be interested in. The scope of this is pretty large, so it didn't really make sense to have a very slow tutorial on building a Kubernetes app. This is more like our show and tell. I've been nerding out for a couple of weeks learning Kubernetes and put it on Raspberry Pis for whatever reason. So our second app is our crypto app, which is the much more interesting one. And this takes data from a cryptocurrency public API, sends it, we handle that all through Kubernetes, send it up into AWS Timestream, and we can visualize it with Grafana. And all of that in Kubernetes uses secrets, or two secrets, one config map, a job with multiple containers, and a service. And we explained how our services work and the networking behind that, and how Kubernetes works, and what all these different API types are in Kubernetes. So that's pretty much a wrap for what we have for today. And like I said, I will probably write a more detailed README than this. This is just like a basic overview of like what we have. The YouTube stream and the slides with just links should stay the same. And I plan to write something more in depth to show exactly how we went through this, and that way you could recreate this if you wanted to, and go out and buy yourself a Pi and build what we have, or something equivalent to it. And that's the plan in the future. But for now, this is the end of the talk. If you guys have any questions, we'll plan on staying on for a few minutes. And any questions for Kevin on his financial advice? I'm sure he's happy to help.
Yeah, what did you do, and what is the opposite of that?
Yeah. Yeah, or let us know like what could be a talk for next time that you'd be interested in, like a couple of options. I could type out like we could talk about Prometheus, we could talk about more Kubernetes stuff and go a little bit slower, more in depth, and the nitty gritty of everything, or we could build a larger application that's maybe more complicated in Kubernetes that builds off of this. Probably don't want to start from scratch. Maybe build something more in depth with our crypto app with Grafana inside of EKS. Probably not going to do anything more on the Raspberry Pis. Post a comment or send us a message on what you'd be interested in seeing. And if you have any more questions for anything outside of the meetup or anything at all, there's both our LinkedIns. Feel free to connect with us. That's about it. Stay on for a couple of questions and see if you guys have anything. Oh, and definitely check out this book if you're just getting into Kubernetes and want to learn like basic details about all the different resources in Kubernetes. It's only like 100 pages long. It's pretty short, 150 pages. And it does a pretty good job of outlining everything. Even though it's a couple of years old, things haven't changed too much to where you're going to miss anything. What do you think? Do you have anything?
No, I mean, good job on the Kubernetes part, man. It's complicated. EKS really provides so much, like, nicety.
Yeah, I spent way too much time thinking I could somehow get internet access, and it was my fault.
Oh, it's definitely your fault. Good job on that stuff. That's super complicated.
Sweet. Well, I think we're about to wrap it up. Maybe give it like another minute.
Cool. Well, thanks to everyone for tuning in. And like Austin said, do let us know what you'd like to see. I'm pretty nerdy about just about anything, so. Yeah,
forever else is on here. I've been like geeking out over Raspberry Pis lately, as you can see, and I plan on building a robot of some sorts in the future, and maybe talking about some robotics. So stay tuned for that in the next, 6 months.
We could do that in a couple weeks.
Yeah. Well, shoot, maybe. No, probably not. Something very basic in a couple of weeks. So
I was kidding.
Give it a few months, and we might have some robotics going on. So, otherwise, we're gonna close it out. Hope everybody has a good night.
Thanks, y'all.
Talk to you guys later.